All right, so who's got the reference angle? Anyone? 6 5/15? 6. That's what y'all all say. Okay. And that would simplify, wouldn't it? 6. Yeah, 6. This one, I think, this angle simplifies too. But yeah, so to get the reference angle, we need the coterminal angle first, right? So to do that, take our big angle, 2, 9. This is probably boring to you at this point, right? Because you're so good at it. You divide by 30, and then you add back plus 987, 653, and then you remultiply by 30, and you get -9. That's negative, so you add a full rotation to it, which is 30. And the coterminal angle is 21. So you need to figure out, let's see, we'll write that down first. 21 pi/15. And you need to figure out where that lives. So here's 15 pi/15. And then half of 15 is 7.5. So yeah, I know that I need to go past 15, so I'm not going to work backwards here. But 15 plus 7.5 is 22.5. Yeah. So I know it's going to live in this quadrant here. And then if you label that as 21 pi/15, now you get from 15 to 21 by going 6 pi/15, which simplifies to 2 pi/5. Okay. So same thing, same answer. All right, cool. Easy, 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 easy. Almost too easy. It's not even fun, right? There is such thing as that easy. All right, we're going to quiz tomorrow over examples as I put up there, 4 and 5. I got to sit down. My back is hurting already. Just left over from Monday's excitement under the sink. Well, that sounds like the name of a good Hollywood movie, right? Excitement under the sink, like a blockbuster, like high action involving like Tom Cruise, maybe some karate scenes. Yeah, that's right. Okay. So let's take this and cross it out if we haven't done that, because you don't need to know that, right? Because you're going to know it another way. All right. So we were on example 3. We had gone through the process of listing all 6 trig functions, and now we wanted to find the angle. So to find the angle, let me just delete the warm up there. To find the angle, we can take any one of these 6 equations that we created. You probably want to stay away from the right column because your calculator only has sine, cosine, tangent buttons. And then of the ones in the left column, any of them will work, but we chose the sine one for 2 reasons. It's the simplest ratio of the 3 because there's no radicals. And it's also the one that was given to us, so we know 100% that it's correct. Not that ours are wrong. So what we do is we write it down, and we need to solve for theta. So what I will have you do is to show me the equation you're solving. So that's rewriting it down like this. And then you got to solve for theta. So the way that we solve for theta is we undo sine. The way you undo sine is by taking what's called the inverse sine of both sides. That's what this is called. It's called inverse sine. And it's an operation, so it goes in front on both sides. Now on the left side, inverse sine of sine, as we've seen so many times this year, when you compose 2 inverse functions back to back, they undo each other. So we're just left with theta equals inverse sine of 5/6. Now you don't have to show the line in red there. If you want to go straight from here to here, that's fine. I know what you're doing, right? We like we don't show dividing by 5 when we're trying to solve if it were 5 times x. Go straight to there. All right, so now we have something we can type into the calculator. But here's the deal. Your calculator has both modes. So whenever you hit one of these buttons here, sine, cosine of the tangent button, sine, cosine, tangent, if you ever, for whatever reason, press one of those buttons when you're doing a calculation, you need to make sure that your calculator's in the right mode. What the heck? And what do I mean by the right mode? Well, degrees are radians. We have not even considered putting our calculator in the right mode up to this time because we've been doing the problems on our own. Like we know it's in degrees, we divide by 360. We know it's in radians, we divide by twice the denominator. The calculator hasn't need to know if those numbers were in degrees or radians. But whenever you hit the sine, cosine, or tangent button, for any reason, it has to interpret either the input or the output as an angle. So if you go to your mode button, which is just to the top left there, to the left of the second button, look at the third row, right? Radians is default highlighted. So whenever you reset your calculator, it automatically goes back to radian mode. We're in degree mode here. So we need to manually go in, highlight degree, and hit enter. Okay. Now it's in degree mode. Get back to the home screen now, second mode. Okay. And we'll clear that out. All right. So now we're ready to type in inverse sine of 5/6. And the way we type in inverse sine is if you look on the sine button, the second feature has sine to the negative first, which is not really the reciprocal of sine, it's the inverse sine. So hit second sine of 5 divided by 6. Okay, and hit enter. Now let's write that angle down that the calculator gives you. I'm not going to call it theta. I'm going to call it phi. Okay, let's call the calculator's angle. Well, let's do this. Let's call it C for calculator's answer. Okay, we'll just call it C every time. C for the calculator's angle. It's 56.442 ... degrees. Now, is that the answer that we want? No. If you remember back over here, our angle's supposed to be in quadrant 2. It's supposed to be between 90 and 180 degrees. The calculator gave us an acute angle between 0 and 90. So how do we get the calculator to give us the angle we want? Well, I don't know. Let's type it in again. Second sine of 5 divided by 6. But this time, let's tell the calculator, give me the other angle in quadrant 2, please. And then hit enter. Crap, it still gave me the same one. Well, how about this? Let's try it again. Second sine of 5/6. And we'll say, come on, dang it. And then we'll hit enter. Come on, dang it. What's that? With sprinkles on top. And it still gave me the same answer. Well, you know what? The calculator is only going to give you one answer. And if you ever type in inverse sine of 5/6, it's always going to be this angle. Always. You know why? Because if you go back to the mode button, not only are we in degree mode, but look at the fourth row. We're in function mode. We're in function mode. And remember what makes a function a function? For every input, there can be no more than how many outputs? 1. And the calculator is going to give us that 1. It's programmed to give us 1 and 1 only. Now we'll learn later on why it gives us that one. Because there are infinitely many angles that have sine of 5/6, right? They're all coterminal with each other. Coterminal angles have the exact same trig functions because they terminate at the same place. So of the infinitely many angles, how is the calculator supposed to know which one we want? It's always programmed to give us this one. Well, here's the good news. The calculator won't always give you straight up the answer you're looking for because that's too easy. So why is that good news? Well, because you get to have a little more fun. And then there's more good news, which is even more good news, right? So the good news, the second good news is that there's more good news, and that more good news is this. The calculators, I'm going to write this down. The calculators answers reference angle, double possessive there. Reference angle is the same as your reference angle. Exclamation point. So what does that mean? That means if you can find the reference angle of the calculator's answer, that's the same as the reference angle of the one you want. And then once you know your reference angle, right? If you come over here, once we know our reference angle, we can find our angle just by, in this case, from our picture, doing 180 minus that. Yes? Okay. So let's see why the calculator's answer is going to be the same as our reference angle. We told the calculator to give us an angle whose sine is positive 5/6. Positive 5/6. In which two quadrants is sine positive? 1 and 2, right? Because remember, sine, y, height, sine, y, sine. So sine is positive when y is positive. Where is y positive? Above the x-axis. Yes? In quadrants 1 and 2. Positive, positive. So it thinks that we want the one over here. Now, because it has the not only the same SIG and sine, but it has the same sine ratio, 5/6. This is also 5, and this is also 6. What do we call those two triangles then, if all of their sides are the same length and the angles are the same? Well, they're not only symmetric to each other, they're congruent to each other. Congruent. It's the exact same triangle. It's just reflected across the y-axis. The side lengths are exactly the same. Okay. So I guess this one over here, this x happens to be positive square root of 11. Those two triangles are exactly the same length. Okay. And there's actually two more of them that have the same reference angle. If you were to reflect these two triangles straight down, you would have them in quadrants 3 and 4. So there's always 4 triangles within one rotation that have the same reference angle. The calculator gave us this answer here. That's what we're going to call C. Okay. So they have the exact same reference angle because it's the exact same triangle, just oriented differently. So now that we have that plan, let's go ahead and find the reference angle of our calculator's answer. Okay, the calculator gave us 56.442. What is the reference angle of 56.422? 56.442, because it's already a quadrant 1 positive angle. So not only is this C the calculator's answer, but it's also theta ref. Okay, awesome. And so what does that mean? That means now we can find our angle theta. So theta for us, based on a diagram, is 180 minus the reference angle. And so if I go back to my home screen, it's on the previous line right there. So I can just hit 180 minus second negative, which recalls the answer in all of its decimals. And I get 123.557 degrees. Now I'm going to store this. Let's store this as X. If you store it as X, call it X on your paper. Okay, now is 123 degrees between 90 and 180? Yeah, the calculator is never going to give us that one though. But here's what's cool. We can check to see if it works. Okay, let's check to see if it works. Let's come back over here. If I take the sine of that angle, it should give me 5/6, right? Let's try it. Sine of X. I get 0.833323, which if I hit math enter is 5/6. Boom. Yeah. Now let's see if it works for the others. If I take the cosine of that angle, it should give me negative square root of 11/6. Well, square root of 11/6, that's an irrational number. So let's type in cosine of X. I get a negative number. If I hit math enter, it's not going to convert, right? It's irrational. But since I know what the answer is, negative square root of 11, I could just type it in. divided by 6 and compare the two decimals. Oh yeah, it's the same. And since we're here, you might as well check the last one. What's tangent of x? Tangent of x. Tangent of x. It's negative 1.507. And what is 5 divided by the square root, negative square root of 11? Same thing. Got it. We did it. Yeah, sweet. Pretty cool, right? So because I design the questions, I'll always design a question where the calculator is probably not going to give you the answer we're looking for. But the calculator's reference angle is the same reference angle that we want. So it comes down to finding the reference angle. Now, let me show you another way to do this problem. Not that that way doesn't work, but it's nice to have options. What if I would have chosen the cosine to solve that one for theta? Should I get the same answer? The way you know math is supposed to work? Yeah, it's the same theta. Can we use that then, not just to verify once we have theta, can we use it to figure out what theta is? And the answer is, I hope so, right? So I'm running out of room. Let's come down here. I'm going to write it out. Cosine of theta is negative square root of 11 over 6. And now I'll take the inverse cosine of both sides. But I'm not going to show that step. I'm just going to go straight to theta equals inverse cosine of negative square root of 11 over 6. Okay. Now, because it said I wanted the answer in degrees, I'll just do a quick little check to develop a good habit. I will check my mode. I am in degree mode, so that looks good. And now we'll type it in, right? Second cosine of negative square root of 11 divided by 6. Big bucks, no whammies. Come on, angle. Well, what do you know? 123.557. Is that the angle that we wanted? Yeah, that sure is. Oh, I don't need to find that guy's reference angle just to subtract 180, that number from the, that's the answer we wanted. So if I would have used this right away instead of inverse sine, it would have given me the answer without having to do all that extra work. You think inverse cosine always gives you the answer you want? No. It depends on where that angle that we're looking for terminates. Sometimes using inverse sine, sometimes using inverse cosine, sometimes using inverse tangent will give you the one you want. But here's the deal. Whether it gives you the one right away that you want or not, we'll learn later on how we can decide that beforehand. I don't want to give that away because it gets into principal value range and restricting domains and talking about the way your calculator is programmed. So right now, just realize that if it happens to be the one you want, you're good, right? But if not, you can always use the calculator's reference angle to find your angle, because it's going to be the same reference angle as yours. And just for kicks and giggles, let's see. If I would have done the inverse tangent, second tangent of 5 divided by negative square root of 11, I wonder what this one's going to give me. Holy moly. This one gives me negative 56.442. What quadrant does that guy live in? Quadrant 4, right? Yeah. So tangent is negative in quadrant 4 when x and y are opposite signs, and in quadrant 2, the one we want, where x and y are opposite signs. It didn't know I wanted the quadrant 2 angle, so it gave me the quadrant 4 angle. But notice it got to quadrant 4 not by going all the way around. It got to quadrant 4 by going straight down to it. What's the reference angle of negative 56.442? Positive 56.442. Yeah. So again, it's the same reference angle. So there you go. You can use sine, cosine, or tangent, either one of them. And as long as you know that the calculator's angle's reference angle is the same as your reference angle, you've got it. Now, could you have used one of these three to find theta? It would be a lot more work because your calculator doesn't have a cosecant, secant, and cotangent button. In fact, here's what you would do. If you wanted to use the cosecant ratio, you would actually have to first put it in terms of sine. That's how it's going to work with your calculator. So because cosecant of theta is 6/5, sine of theta is 5/6. And now you take the inverse sine of the sine ratio, 5/6. Okay. So basically, if you start on the right column, you go directly to the left column. Okay. Kind of fun, right? Kind of. And by kind of, I mean like a whole lot. Yeah. All right. Now that was an easy one in terms of identifying the quadrant in which it lived, because clue number 2 was basically a confession, right? So let's jump down to example 4. Example 4 and 5 are done exactly the same way once we identify the quadrant in which it lives. The only difference is the second clue is a little more esoteric. Oh, that could have been the word of the day, but I got lazy and didn't change any of the quotes. So the words of the day are still, flaneur, and assuage, and now esoteric. Okay. What does esoteric mean? Kind of hidden and secretive, right? Vague, right? Oh, I saw the cutest little video this morning. It's a dog. I follow a pet account, and is a good boy, and he's standing behind a curtain, and the curtain is just draped over his eyes and resting on his nose, and you can totally see the dog just standing there, but he thinks he's invisible because his eyes are covered. He's just like, oh, he's a good boy. Yeah, I like dogs. Example 4. If tangent of theta is 5/12 and cosecant of theta, cosecant of the same angle theta is what? Less than 0. What does that mean? Negative. Determine the simplified exact value of the other 5. So everything is the same after that. Okay. Okay. Esoteric. Here we go. Let's take the first clue. Tangent of theta is what type of 5/12? Positive, right? That's the first clue. Tangent of theta equals positive 5/12. Now you see I wrote the plus sign in front just to accent it. All right. So let's go ahead and draw a picture. That's going to get us into 2 quadrants. Not quite. Remember, tangent is y over x. So y and x can both be positive or both be negative. So, or any combination. So tangent is positive when x and y are the same sign. Okay. Quadrant 1 is the first one, right? We want them to be the same sign. So it's quadrant 1 where they're both positive, or quadrant what? 3 where they're both negative. Yeah. All right. So there's the first clue. The second clue, cosecant of theta of the same theta is less than 0, is negative. Well, cosecant is r over y. R is always positive. So just like sine, its reciprocal is negative when what is negative? When y is negative, right? Sine, y. Sine is negative when y is negative. Cosecant is negative when y is negative. Where is y negative? Quadrant 3 and 4. Very good. Yeah, yeah. We know the answer is 3. So what's the overlapping quadrant? 3. Yeah. So you don't have to shade them. If you wanted to put like dots, like here's one dot, here's another dot, and then there's a dot, there's a dot. It's the one that gets 2 dots. Okay. Or you can just do it in your head. It's like, oh, okay. 1 and 3, 3 and 4. I said 3 twice. It's quadrant 3. All right, boom. So now, again, I'll just draw a terminal ray kind of on the 45, and there is my angle theta. Make sure you're drawing the arc and then saying theta. Okay, so that's it. That's really the only difference from the first example, is the second clue, implies 2 other quadrants and you're looking for the overlap. Questions on how I did that? All right, so now it's the same. We'll drop a perp, creating a reference triangle. We'll label the sides. It's 5 and 12, 5 and 12. Now here's where again, we have to be careful. Tangent is y over x. So it's 5 for the y and 12 for the x. But is that right? The lengths are 5 and the length is 12. But we're on coordinate geometry. So to get to this point down here, we have to go left and down. It should be what? -5 and -12. Yeah. So just pay extra close attention to the SIGNs of your numbers when you label them on the diagram. Okay. They're both negative. Now we're going to find R, and by the Pythagorean theorem, -5 squared plus -12 quantity squared equals R squared. So R squared equals 25 plus 144. That's 169. So when I take the square root, I know R is either equal to -13 or +13. By the way, if the radical is not a perfect square, we don't put a decimal approximation of it. We leave it as a radical, and then we simplify it if we can by pulling out common factors. But this is a Pythagorean triple, your old 5, 12, 13. All right. Which one do we want here for R? The negative or the positive? Yeah, very good. For R, we never want the negative, right? For R, we never want the negative. I wrote the negative there. But for X and Y, we could possibly want the negative. All right. So now that we have all three sides, now it's time to list them, right? Let's list the trig ratio. So we'll do SOHCAHTOA, sine of theta, cosine of theta, tangent of theta. If you want to write the definitions in terms of X, Y, and R like we did on the first one, you can. I think I'm just going to skip that. All right, so we'll pull the ratio from the triangle. Sine is y over r, so that's going to be -5 over 13. Cosine is x over r, that's -12 over 13. Tangent is y over x, that's -5 over -12, which is 5/12. And again, that's the same as what we were given. So again, it's nice to just relist it, include it in the set of 6, and compare it with what we started with. It's a good check. Now, because there's no radical here, it was a perfect Pythagorean triple, we don't have to rationalize any denominators. And then in the second column, we got the reciprocals, cosecant of theta, secant of theta, and cotangent of theta, right? And I would again say pull them off the triangle. Don't just flip the first column. Pull them off the triangle. Cosecant is r over y, so that's 13 over -5, or -13/5. And of course, you compare it, and you're like, yeah, that is the reciprocal of sine. Secant is r over x, so that's 13 over -12, or -13/12. And yeah, that is the reciprocal of cosine. Cotangent's x over y, so that's -12 over -5, which is 12/5. And yeah, that is the reciprocal of 5/12. So again, comparing it to the first column, they should be reciprocals. When they are, that means that you've set it up and you're doing it right so far. All right, so that takes care of the non-calculator portion of this problem. Now we just need to pick any one of the functions from column 1. Okay, so we can solve it. None of them have a radical, but the best practice may be to choose the tangent, just because we know it's correct. It was given to us. And if we made a careless mistake on like the Pythagorean theorem, you know, the other two could be wrong and we don't even know it at this point. So I'm going to go ahead and choose that one. So here we go. I'm going to write it. Tangent of theta is 5/12. And now I'm going to take the inverse tangent of both sides. We don't have to show that step. We just show this step. Theta is inverse tangent of 5/12. Now, before we go to the calculator, let's check to see what we're supposed to be in, degrees or radians. Oh, it says find it between 0 and 360 degrees. So we need to be in degrees. So let me check that again real quickly. Hey, I'm still in degrees. What do you know? That's good. Go back to the home screen. Let's flush. And now we'll type it in. Second tangent of 5 divided by 12. And I'm going to write this down as C for calculator's answer. And it's 22.619 ... degrees. Is that the answer? Is that the one we want? No, no. So again, if you look at our first diagram when we shaded it, tangent was positive in quadrants 1 and 3. I told the calculator to give me an angle whose tangent is positive 5/12, and it gave me the one in quadrant 1. It didn't know I wanted the one in quadrant 3, but I can use the calculator's reference angle to find mine. So what would the reference angle be? 22.619. So yeah, this again is also my reference angle. It's not just C ref, it's theta ref, okay? And so now I'm going to use my diagram to tell me how to get theta from theta ref. What do I do? Add 180 to it, right? Because now I can see I'm all the way at 180 plus the reference angle amount. So my angle theta should be 180 degrees plus theta ref, which I could just, again, on my calculator, say plus 180. Boom. Then we get 202. So theta is 202.619 degrees. I truncate. Now let's store this as x again, because I want to verify it. I want to verify it with the sine, cosine, and tangent. Stored it as x. Now we can come up here to the first column, and let's just verify. Sine of theta, so sine of x, gives us that. And when I hit math, enter, I get negative 5/13. Boom, that's what I wanted. Cosine of that angle, cosine of x, gives me that. I hit math, enter, I get negative 12/13. Looking good. And then finally, the last one, tangent of x. If I hit math, enter, I get 5/12. So they're all three there. Been easy. Been easy. All right, just for kicks and giggles. Remember on the previous problem when I used the cosine actually gave me the angle that I wanted. You might be thinking, I wonder if cosine always gives you the answer that you're looking for without extra work. Well, let's see. I'll write it down. Cosine of theta is negative 12/13. So theta is the inverse cosine of negative 12/13. And now if I type that in, second cosine of negative 12 divided by 13, it gives me, oh, I can't call that theta. I got to call it C. The calculator's answer is 157.380 ... Darn it. Is that the answer I wanted? No. So which two quadrants is cosine negative in? Cosine is negative when x is negative, right? So cosine is negative in quadrants 2 and 3. I just took the inverse cosine of a negative ratio. I wanted the one that was in quadrant 3, but the calculator's like, I don't know which one you want. So it gives me the one in quadrant 2, right? Yeah. So not a big deal. I can find the reference angle of the calculator's answer by subtracting it from 180. So 180 minus the calculator's answer gives me the reference angle, 22. And now I can look at my picture and say, I want to go that much further past 180. So if I add 180 degrees to it, now I get my angle. Okay. So there you go. What's cool is that you do have to do a little bit of thinking, and you do get to use the calculator. But the calculator, while it may not always give you straight up the answer you want, it always gives you an angle whose reference angle is the same as the reference angle you want, right? I hope you're getting that from today's lesson. All right, how much time? Oh, we got time. Let's do this last one here. So example 5. We'll do example 5, and then tomorrow we'll quiz over one problem like this. Yeah? Pretty good? Okay. Let's see if we can do this one relatively quickly. If cotangent is -2 and cosine is positive, same question. And we're between 0 and 360. All right. Step 1, let's write down cotangent of theta is what type of 2? -2. Now you can make that look more like a ratio by putting it over 1. Okay. Cotangent's definition in terms of x, y, and r is x over y. So cotangent is negative when x and y are what? Not the same, because that's when they're going to be positive. A positive over positive is positive. A negative over negative is positive when they're opposite, right? Yeah, tangent would be -1/2. Good. So yeah, which two quadrants are those? Where are x and y opposite? 2 and 4. So quadrants 2, where it's -x positive y, or quadrant 4, where it's positive x negative y. So the first clue puts us in those two quadrants. Okay, let me go ahead and just say that here. This is quadrants 2 and 4. And now the second clue. The second clue says cosine of theta is greater than 0. Cosine, remember, is x over r. So cosine is positive when x is positive, right? And x is positive in which two quadrants? 1 and 4. So if you shade that, cosine is positive when x is positive. That's 1 and 4. Where's the overlapping quadrant? 4, right? So there you go. You use the two clues to figure out the quadrant. So there's your theta. All right, now we could drop a perp and we label the sides. X is 2. I like to do the magnitudes first. X is 2 and y is 1. Now, one of those is negative. Which one is negative based on the configuration here? The y. Good. So just because it's -2 and you put it over 1, you write it as the -2 being apparently the -1, but it's not. It's negative because the one is negative. Okay. So now we can use the Pythagorean theorem to find r. So we get -1 squared plus 2 squared equals r squared. So r squared equals 4 plus 1 is 5. R is equal to the negative square root of 5 or the positive square root of 5. Which one do we want here? Since we're in quadrant 4? Yeah, the positive. We never want the -1 for r, but x and y can be positive or negative. Now that we have all three, we list them, right? Sine of theta is y over r. So that's -1 over the square root of 5, which we need to rationalize that. It's negative square root of 5 over 5. Cosine of theta is x over r. That's 2 over the square root of 5. Again, we need to rationalize that. So that's 2 square root of 5 over 5. Tangent of theta is y over x. So that's -1 over 2 or -1/2. All right, so there's the first column. Make sure you simplify your radicals. The square root of 5 has no perfect square factors. And now you rationalize, right? Multiply by square root of 5 over square root of 5. Okay, the next column, the reciprocal of sine is cosecant. And the reciprocal is going to be, well, let's see. We'll pull it straight off the graph again. So it's r over y, which is square root of 5 over -1. which of course is just negative square root of 5. Secant is r over x, so that's square root of 5 over 2. And then of course cotangent is x over y, and that's 2 over negative 1, which is negative 2, and that's what we were given. Okay, so there's all 6 of them. All right, which one of those ratios in the first column do you feel like using? I feel like using tangent as well, just because, again, it was implicitly given, but it doesn't have any radicals. So tangent of theta is negative 1/2. So theta must equal the inverse tangent of negative 1/2. And again, we're in degrees, so now we can go to the calculator. Second tangent of negative 1 divided by 2. And the calculator's answer is negative 26.565. What quadrant is that in? It's in quadrant 4, isn't it? But it's not the angle we want in quadrant 4. That went straight down to get there. We want to go all the way around. So again, we can find the reference angle. No, not quite. Right, there we go. So now I'm going to say the reference angle is positive 26.565. And now theta, of course, you can look at your diagram. We have to stop the reference angle short of a full rotation. So by your picture, it's 360 degrees minus the reference angle. Or you can say, hey, negative 26.565 is coterminal with the one I want. I just want it to be one rotation away. So either way, on your calculator, you can either say plus 360 in this case, or do 360 minus the positive version, and you get 333.434 degrees. And then if you wanted to store that and check, you can compare it to the others, and you'll see that it's correct. Okay, that's it. You can clear your calculators, turn them in, and we'll quiz tomorrow over one problem like this, or maybe 2 problems, because it's so much fun. We'll see. There are problems like this in the worksheet. There are also, if you're interested, I haven't assigned it yet, but if you're interested, if you go to the website, there's a 2's Clues extra practice. If you really want to extra practice for the quiz tomorrow, come down here and go to, see how it says right here, 2 Clues take-home quiz, 2 Clues take-home quiz. There they are. There's 4 questions and the answer key is posted. So you should make 100 on your quiz tomorrow. Have a good day.